Hello students, welcome back to Lakshya Education Online. This is episode 3 of chapter number 15, probability. Now moving on to the next question, question number 17. It contains two questions. Number one is a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. Then what is the probability that this bulb is defective? Let us solve this question. You have the question in front of you. Once again, a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? So first of all, here we have total number of bulbs equal to 20. Out of these 20 bulbs, we have number of defective bulbs 4. So what will be the number of non-defective bulbs? The number of non-defective bulbs will be total minus defective. 20 minus 4, that is 16. In the first question, we have to get the probability that the selected bulb is a defective bulb. Suppose we call it P of A. According to the formula, number of defective bulbs upon total number of bulbs. What is the number of defective bulbs? It is 4 and total number of bulbs is 20. So your answer will be 4 by 20. We get 1 by 5. So the probability that the selected bulb is defective bulb, it is 1 by 5. Now the further question is, see the question carefully. Suppose the bulb drawn in first question, means the previous one, is not defective. Earlier we have got probability for defective bulb, but suppose we assume that the bulb which was selected in the first case, it was not defective and not replaced. We have not replaced it, means whichever bulb we have picked up, it is not defective and we have not replaced it, means it has been taken out. Now one bulb is drawn at random from the rest of the bulbs, means the remaining bulbs. What is the probability that this bulb is not defective? I explain the question again. In the first experiment, whichever bulb we have picked up, it is a non-defective bulb, means it is a good bulb, and we have not replaced it. It means we have taken it out. As we have taken non-defective bulb out, means now the number of remaining bulbs will be, earlier we had total 20 bulbs, one bulb is taken out, means now the remaining number of bulbs will be 20 minus 1, that is 19 bulbs. So now we have total 19 bulbs remaining. The one bulb which we have taken out is non-defective. Earlier we had 16 non-defective bulbs. Out of them we have taken out one non-defective bulbs and it is not replaced, means it is taken out. It means the remaining number of non-defective bulbs will be 16 minus 1 is 15. 15 non-defective bulbs are remaining. Total number of bulbs are 20 minus 1 is 19. Now we have to get the probability that the one bulb which is picked up is non-defective. Suppose we call this probability as P of B. Now as we have to get the probability that the selected bulb is non-defective, means number of non-defective bulbs upon total number of remaining bulbs. Now the number of non-defective bulbs is 15 and total number of remaining bulbs is 19. Therefore the probability in second case will be 15 divided by 19, 15 by 19. This is your answer. The next question is number 18, and is a box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears, and 3 questions are given. The first one is a 2-digit number, the second one is a perfect square number, and the third one is a number divisible by 5. Let us solve this question. A box contains 90 discs which are numbered from 1 to 90. So here the total number of outcomes is 90, as we have total 90 discs. The first question is a 2-digit number. We have to get the probability that the selected disc is a 2-digit number. So first of all we have to get how many two-digit numbers are there from 1 to 90? Out of 90, 1 to 9 number are one-digit numbers. So here 1 to 9 numbers are one-digit numbers. But we want two-digit numbers. Rest of the numbers are two-digit numbers. It means number of outcomes for two-digit number will be total outcomes minus one-digit numbers. It is 90 minus 9. 1 to 9 are one-digit numbers, means 90 minus 9 we get 81. So in this case our number of favorable outcomes are 81. Now according to the formula, if we call this probability of A, event A, in this case number of favorable outcomes is 81 and total number of outcomes is 90. 81 is 9 multiplied by 9, 90 is 9 multiplied by 10, so our answer is 9 by 10 or 0.9. Let's move on to the second one. Find the probability that the selected number is a perfect square number. A perfect square number is a number which is a square of any number between 1 to 90. Which are the perfect square numbers from 1 to 90? They are 1. 1 is a square of 1, so it's a perfect square. Now the square of 2 is 4, so 4 is a perfect square. Square of 3 is 9, so 9 is a perfect square. Square of 4 is 16, it is a perfect square. Square of 5 is 25, square of 6 36, square of 7 49, square of 8 64, square of 9 81. What are the number of favorable outcomes in this case? 1 2 3 4 5 6 7 8 9. Suppose we call this P of B according to the formula. Here number of favorable outcomes are 9, total number of outcomes are 90. 9 divided by 90, that is 1 by 10, so your answer is 1 by 10. You can also write 0.1. Now let us move on to the third one. The question is, find the probability that the selected card or the disc has a number which is divisible by 5. So favorable outcomes means the numbers which are divisible by 5 from 1 to 90. That is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85 and 90. How many favorable outcomes are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Therefore, number of favorable outcomes is 18. The probability, if we assume it P of C equals to number of favorable outcomes is 18, total number of outcomes is 90. We know that 18 into 5 is 90, so it will be 1 by 5. So your answer for this question is 1 by 5. The next question is question number 90. It is, a child has a die whose 6 faces show the letters as given below. On the 6 faces of the dice, the numbers are not marked. Here 6 letters are marked as shown in your textbook. They are A, B, C, D, E and A. On each surface one letter is marked and we have to get the probability of getting number 1 A and number 2 D. In case of a die, the total number of outcomes is 6. So you have got the denominator of your answer. Total number of outcomes is 6. Now the question is, number 1, when it is thrown, you get A on it. Here A is marked on 2 different surfaces. It means in this case, number of favorable outcomes is 2. Probability for A, P of A equals to number of favorable outcomes upon total number of outcomes. Number of chances for A on the die upon total number of chances. So it will be 2 by 6 because 2 times A, that is 2 chances, and 6 total number of chances. 2 by 6 we can get it 1 by 3. So your answer will be 2 by 6 or 1 by 3. The second question is probability of getting D. Now see here, D is for one time only. Number of chances for D upon total number of chances. D is for one time, therefore the answer will be 1 by 6. Let's move on to the next question. Next question is question number 20. It's a good one. See, the question is, suppose you drop a die at random on the rectangular region as shown in figure 15.6. What is the probability that it will land inside the circle with diameter 1 meter? So as shown in the diagram, there is a rectangle with length 3 meter and breadth 2 meter. There is a circle drawn inside of it. Diameter of this circle is 1 meter. It means its radius is half, 1 by 2 meter. Now if one die is thrown on this region, then what is the probability that the die will drop in this circular region? Now according to the formula of probability, the formula is P of E equals to number of favorable outcomes upon total number of outcomes. But in this case we don't have any number of outcomes. Here as this is a region. So here in this case the favorable thing is not number of outcomes, but the favorable thing is favorable region area, or we can say area of the favorable region and area of the total region. Here the total region is a rectangular region and the favorable region is circular region. So the formula will become P of E equals to area of favorable region upon area of total region. Now the total region is rectangular region. It means area, if we want its area, then we need to get area of rectangle. But we know that area of rectangle, its formula is length into breadth, L into B. Here length of this region is 3 meter and breadth is 2 meter. Therefore L into B will be 3 multiplied by 2, that is 6 meters square. So here in this case the area of total region is the area of rectangle equal to 6 meters square. Now we want to get area of favorable region, which is circle with diameter 1 meter. That means the radius of the circle is 1 by 2 meter. What is the formula to get area of circle? We know that it is pi r square. So pi multiplied by, what is r? It is 1 by 2. So pi into 1 by 2 square. So we get pi multiplied by 1 by 2 square will be 1 by 4. So area of circle is pi into 1, it is pi divided by 4. So we get it pi by 4. So here area of favorable region is pi by 4 and area of total region is 6 meter. Now according to the formula, P of E, probability of E equals to, so area of circle divided by area of rectangle. We got area of circle equals to pi by 4 divided by area of rectangle equals to 6 meters square. We will get pi upon 4 multiplied by 6. So our answer is pi by 4 multiplied by 6 is 24. So the probability that the die will drop in the circular region is pi by 24. This is your answer. Next question is question number 21. See the question. A lot consists of 144 ball pens, of which 20 are defective and the others are good. Noori will buy a pen if it is good and will not buy it if it is defective. The shopkeeper draws one pen at random and gives it to her. We have to find the probability that number 1, she will buy it, and number 2, she will not buy it. Let us solve this. Now in this case the total number of ball pens is equal to 144. Total number of ball pens are 144, of which 20 are defective. So here number of defective pens equals to 20. Therefore number of good pens will be total pens minus defective pens. that is 144 minus 20, we get 124 pence. Now the probability that she will buy this pen, so suppose I call it P of A. P of A, she will buy it only if it is a good pen. So number of good ball pens upon total number of pens. 124 divided by total number of pens, 144. So your answer is 124 upon 144. We can get its reduced form. Let us see how. Both of these numbers can be divisible by 4. 31 multiplied by 4 is 124 and 36 multiplied by 4 is 144. 4 will be cancelled out. So your answer will be 31 upon 36. So the probability that Noori will buy this pen is 31 upon 36. Now the second one, probability that she will not buy it. Suppose we call it probability of B. Number of defective pens upon total number of pens. Here number of defective pens is 20 and total number of pens is 144. So we can write it 20 upon 144. 5 multiplied by 4, 36 multiplied by 4. Therefore the answer will be 5 by 36. So the probability that Noori will not buy it is 5 by 36.